Today I'll be comparing the geo-partitioning features of CockroachDB and Spanner. Spanner is Google's distributed SQL database, and in the latest version of Spanner, it has support for geo-partitioning. Both CockroachDB and of course Spanner were influenced by the Spanner white paper that came out in 2012, and 12 years after that white paper released, Spanner finally has geo-partitioning. In today's demo, I'll pit the two against one another to show you what you can expect from both databases when it comes to geographically partitioning data for various use cases. A few things to note before we begin. Geo-partitioning in Spanner isn't yet GA, it's still in beta, meaning a few things aren't supported yet. These are: the Postgres dialect isn't yet supported for geo-partitioned Spanner instances. You can't create partitions on free instances or instances with less than 1000 processing units. You can't make backups with geo-partitioned Spanner instances. You can't use CMEX, customer managed encryption keys. There's no support for change streams or change data capture. With those disclaimers out the way, let's get cracking. To create a geo-partitioned Spanner instance, you'll need what's called a default partition. This could be in one region, or it could span multiple regions. I'll be honest, I don't 100% know how it works under the covers, so I've created a multi-continent default instance, and then you create partitions on those. I'm creating 3 partitions, one in US East 1, one in Europe West 3, and one in Asia Northeast 1. And to give those applications the best possible chance of low latency for reads and writes, I'm placing those applications as close to the instant partitions as possible. In CockroachDB, I have a 3-region cluster, one region in US East 1, one in Europe West 1, and one in Asia Southeast 1, which is Singapore this time, not Tokyo. And as with Spanner, I'll be running my applications as close to the database regions as possible. Let's go through the infrastructure quickly. I'm creating my multi-continent Spanner instance with 3 nodes. I'm creating a database called store. I'll be storing products, and a service account that can access it. In CockroachDB, I'm spinning up a cluster. I'm running this cluster in GCP just to make sure that both CockroachDB and Spanner are both running in GCP. These are my regions. It's a standard cluster, which falls between our basic and advanced tiers. I'm opening access to everything, and then I'm creating a user. Finally, let's take a quick look at the code. In the Spanner code, I fetch my location based on the fly region that I got. I'm using fly.io as it's a nice, easy way for me to create applications. If I receive Frankfurt, I'll be using the EU partition, Ashburn, Virginia, the US partition, and for Tokyo, the APAC partition. I write my auth file so that I can connect. I create my Spanner client, and then every second I'll write to the database and read from it, measuring how long each of those operations took. For the write, I'm using an insert mutation, generating a random ID and a random product name, and then applying. And for the read, I'm running a single query statement. For CockroachDB, I connect to the database. I fetch my location based on the gateway region that I've connected to. I'm using one connection string in the same way that I'm using one connection string for Spanner, and I'm inferring my CockroachDB region by making a call to select gateway region, which for someone based in Frankfurt will be returned a Frankfurt region. Because we're speaking Postgres now, these are just simple inserts and selects. Let's spin up the infrastructure. I'll apply my Terraform code. With that all completed, I'll move on to the Spanner specific part of the installation. First, I'll alter the database and opt into the data placement preview. This enables geo-partitioning. With that done, I'll create my instance partitions. One will be US. It will be a regional US East 1 instance against the default CRDB geo-partitioning comparison instance, and there'll be one node. Same as EU, same as APAC. With those created, let's see what we've got in Spanner now. I can list my instances, and you can see that I've got my default instance, which is ready to go, and I can list my instance partitions, which shows the default partition and the 3 regional instance partitions. I now have to create placement options for the US, the EU, and APAC, such that whenever the value AP is found, for example, it sends it to the instance partition CRDB geo-partitioning comparison APAC. With that done, let's have a look at those placements. The default instance is default, but AP, EU, and US are not defaults. Let's have a look at the placement options. We can see again that the name that matches, for example, AP, points to the instance partition, geo-partition comparison, APAC. The only thing left to do now is create a table, which I can do with this statement. I'll create a table with an integer ID, a name, and a timestamp. There's also a location placement key that determines into which instance each row will reside. That's Spanner setup. Let's move over to CockroachDB. First, I'll connect to the cluster. I'll enable geo-partitioning by setting a primary region for my comparison database. And finally, I'll create the table. This will be a UUID primary key. It will have a name, a timestamp, and it'll be regional by row, meaning it will get a CRDB region column that's hidden. And that's CockroachDB setup. I'll now run a global workload with users in the US, Europe, and Asia to see what kind of read and write latencies each of them get against CockroachDB and Spanner. With this, I'll create an application in fly.io called CRDB Comparison Spanner. I'll set some secrets, the database identifier, the application credentials, the JSON blob that allows the application to talk to Spanner. I'll build the application into a Docker image. I'll push that image to fly.io. Then I'll deploy it to Frankfurt before scaling it out to Frankfurt, Ashburn, Virginia, and Tokyo. Once the application's running, we can follow the logs with this command. This will collect the logs from each of the 3 regions. The Frankfurt application is starting up, and once that's running, we'll get read and write latencies. I'll let each of the regions start, and then we'll start to look at their latencies. Now that that's been running for a while, I'll stop the logs there, and I'll keep those on screen while I spin up the applications that will talk to Cockroach. We'll start to see some logs now. That's the Frankfurt application starting. And with that running, we're now scaling up to Ashburn and Singapore. And with both of the applications running now, I'll stop logging the CockroachDB applications, and now we'll compare. Let's start with the Spanner logs. The Frankfurt region is seeing write latencies of around 364 milliseconds on average, and write latencies of around 4 milliseconds on average. The Tokyo region is seeing write latencies of around 500 milliseconds on average, and read latencies anywhere from 5 milliseconds to 14 milliseconds. And finally, the Ashburn, Virginia app is seeing write latencies of around 145 milliseconds on average, and read latencies anywhere from 18 milliseconds up to 87 milliseconds. In CockroachDB, the Frankfurt region is seeing write latencies of around 22 milliseconds, with read latencies of around 20 milliseconds. The Singapore region is seeing write latencies of around 6 milliseconds on average, and read latencies of 4 milliseconds. And the Ashburn region is seeing write latencies of around 16 milliseconds, and read latencies of around 15 milliseconds. For 2 distributed SQL databases, CockroachDB and Spanner internally are quite different, and that can be seen from the resulting write latencies that we've observed with Spanner. Although I've positioned the applications as close to the databases as possible, there's still high write latency when talking to those instance partitions. I'm no Spanner expert. If someone knows of a better way to configure Spanner for this workload, your feedback would be very much appreciated. But I'd like to extend my thanks to Christoph Bussler, whose blog post helped me create the Spanner infrastructure. Without that blog post, it might have taken me quite a while longer.